What's up everyone? This is Dariusz Kalbarczyk, co-founder of NG Poland, JS Poland, Angular Master.dev and Workshop Fest.dev. Welcome back to the JavaScript Master Podcast. Today, together with Miško Hevery, who is a CTO at Build.io, creator of Quick, Angular, AngularJS, and co-creator of Karma.js, we will talk about framework comparison. Okay, let's talk today about reactivity in different frameworks.
Yeah, so it's actually a good topic, right? Like every framework essentially says, they're reactive in a sense, but I think there's a big difference between how different frameworks do reactivity. And I think it's interesting to kind of dwell, go deep on it and compare different things. So when I think of reactivity, I think it's important to realize that it's kind of a spectrum, right? Like you can have essentially two extremes, and then the framework can be somewhere in the middle of this extreme. And one extreme would be, every time a state changes, then you just re-render the whole thing, right? And that would be like a coarse reactivity. And the other extreme would be that whenever a state changes, the framework somehow knows exactly just the right thing to update in a UI and do the absolute theoretical least amount of work, right? So that would be, we would call that the fine-grained reactivity. And there is a spectrum between those. And I just want to point out also that, no framework actually re-renders in the sense of like it goes and updates the DOM elements when it's unnecessary. All frameworks are intelligent enough to be smart about talking to the DOM because that's very expensive. Everybody realizes it. So like all frameworks are efficient in terms of talking to the DOM, right? But that's not what we're talking about. We're talking about how do frameworks figure out what actually changed, right? So all frameworks are intelligent in the sense that they always do the minimum amount of work to update the DOM. But figuring out what changed for a framework is a lot of work. Or could be, right? Like there could be two extremes. Like you could have this coarse-grained system, which is very fine-grained, and very coarse-grained. And then the other extreme, you would have something super, super fine. So, again, imagine it as a spectrum, right? The two frameworks that are very coarse-grained are actually Angular and React. And the way they work, right, is that something changes the state, something triggers state change. And when the state changes, the framework has to figure out what changes. And the way this is done in both Angular and React is that you start at some root component, and then you start comparing what the previous state was and what the next state is. So in Angular case, Angular does it on the actual expressions that are inside the UI. It goes and compares every single expression. The way the React does it is it reruns all the components, rebuilds the VDOM, and then compares the current VDOM against the previous VDOM, right? So in both cases, you're kind of doing these manual comparisons through, whether the two VDOMs or the expressions, but essentially it's the same thing. You kind of compare the two. And then if you find the difference, then you have to go and update the UI, right? You have to go and talk to the DOM. And we say it's a coarse grain because the frameworks have to check a lot of stuff, right? If the signal is raised or like something tells the system like, hey, the data has changed, what is the thing that the framework has to do? And in both cases, both in case of Angular and in case of React, it goes and re-executes the components, either in the form of actual functions, like in the case of a React, right? We start at the root component, we re-execute the functions, and as these functions get re-executed, we rebuild the VDOM, and then we compare the VDOM. In the case of Angular, you re-execute the templates. You don't think of the template as the code, but it's really a code, right? And so you're re-executing the templates, and you're comparing this template against the previous template, etc. And so from that point of view, Angular and React really work the same way. It's really just a question of like, am I comparing the input to the template? Or am I comparing the output of the template, which is the VDOM, right? But besides that little kind of difference, everything else is kind of works the same. And once the framework discovers that something has changed, then it goes and updates the UI. So the thing to kind of realize about these frameworks is that they're tightly coupled to components, right? You always start with some kind of a root component, and then you recursively go to the child components. And as you visit the child components, you kind of do the checking to see if there's anything different. And if you find a difference, you update the DOM. Now, all of these frameworks have a way to prune the tree. So like there's a way both in Angular and React to basically say like, oh, I know that you're not going to find any differences in this subtree here. So don't bother wasting time going here. And similarly in React, you can basically say like, hey, I know there's not going to be any difference, through memoization. And so don't go down to this particular branch because you're not going to find anything. It's going to be wasteful, right? And that's kind of how people kind of improve the performance of these systems. But the takeaway here is that out of the box, without any sort of additional work for the developer, it's very tree-based, meaning that the component tree dictates how the computation of differences happens, right? And so the change of the state and the hierarchy of the components are kind of tied together. Okay, so that's the other extreme. The other extreme would be solid, right? And the solid, everything is a signal. And in solid, components never ever re-render. They never ever re-execute. They execute exactly once on startup. And after that, they never ever re-execute, right? So again, if you have somebody coming from React, you'd be like, hey, this is kind of weird. I'm expecting my component to be re-executing all the time. And that's not what's happening in solid, right? They do it once and then never again. And the reason for that is because solid, through signals, is able to build a graph of reactivity. And so while in Angular and React, there's a generic way of saying like, hey, something has changed, do this magic for yourself to figure out what has changed, right? When you work in something with signals, then the message is very focused, right? You say, I've changed this value, right? So instead of saying generically, something has changed, and then framework has to figure out what, that's a lot of work. The other extreme is with signals, you just say like, hey, this input has changed. And now the framework, what it has is has a reactivity graph. It basically says this input is used to produce these two other inputs, which in turn are bound to some DOM operation, right? And so it's very easy for the framework to go and just update the UI. It's very, the steps are really predictable, and it's very easy to just do them. But it's you don't get to do any extra work because you know the graph. You know this depends on this, depends on this. And so you can easily just follow through. Now, in order for that to work, the framework needs to build the graph, right? And so building the graph is kind of the hard thing. And it is basically the thing where the frameworks compete on, right? Different frameworks have either explicit or implicit way of building graphs. So signals are an implicit way of building graph. And other frameworks like, RxJS are explicit. You have to subscribe. So really the DX is what we're going to kind of, talk about between all of these systems. But once you have the graph, if the graph is fine-grained enough, then you can do these direct updates, right? So you can think of solid as being the absolute extreme of like, if you take it to the logical extreme conclusion of like, if I just change this, what do I have to update? And if you could build that graph, you would end up with kind of the solid world. And if you have the opposite extreme, which is like Angular and React, which is you say something has changed, figure out what. That's the case where you don't have a reactivity graph. The closest thing you have is you have the component tree, and then you just follow the component tree, right? So those are the two extremes. And it turns out that the other frameworks kind of fall in between these two extremes, and it's kind of nice to kind of know where they fall. So let's kind of, so we're going to talk about Vue, we're going to talk about Svelte, and let's talk about Quick and kind of compare where they are. And I intentionally talked about Angular and React and then Solid first because I wanted to kind of set the extremes, right? These are the completely left and completely right. This is kind of what you can get. And it turns out the other frameworks kind of fall somewhere in the middle. Okay, so let's talk about Vue. So Vue also has signals, but those signals are tied to components. So when you go and change a value on a signal, what you're really causing is you're causing the whole component to re-render. So in other words, the way to think about it is that view on the level of components acts like essentially Angular or React, in the sense that your finest level of granularity is to say this component has invalidated. Now in Angular and React, when you invalidate a particular component, you're also causing all the child components to invalidate. Whereas in Vue, you may not always need to do that. So in that sense, Vue is a little better. Basically, Vue allows you to prune the tree, so to speak, kind of automatically, right? So in React, when you have a root component that the state has changed, all of the children have to re-render. Vue, when you have a state associated with a component and you want to re-render, it's kind of better at pruning the tree so that you don't kind of go in all the different branches. But it's still tied to individual components. The minimum unit of work for Vue is still a component. So you can't get more fine-grained than that. But Vue does have signals. And the reason why the component is kind of the minimum unit of work is because when you pass signal from a parent component to a child component, in Vue, the signal gets unwrapped and the child component then kind of like subscribes to the parent and then gets rewrapped. And this wrapping and unwrapping means that the parent-child always kind of updates. So let's talk about a concrete example. So imagine you have a counter, very simple component, right? And you have a state where you can count, and you have a button that increments the counter, and then you have a display where you kind of update it. Most counters you probably have seen were written as a single component, right? And because of that, like you can't really see how the magic works, so to speak. So let's break this counter example in a few more components, right? So let's imagine that we have a counter component where we keep the state. But instead of having the button directly inside of our counter component, we're going to have a child component called, let's say, incrementer, right? And then we take the state, and instead of printing it directly inside of the counter, we print it in a separate component called, let's call it display. So now we have a root component, which is the counter, which contains the state, and you have two children, the incrementer and the display. Okay, and to kind of make it even more realistic, let's actually take the display and make it even slightly more complicated. So what we're going to have is we're going to have a counter where the state is, and then let's introduce an extra component called wrapper that doesn't do anything. All it does is passes the state from the parent to the child display, right? So you have now the root component, which is the counter. On the left side, you have the incrementer. On the right side, you have the wrapper, and the wrapper then has a display. And the reason we want to have this extra level of indirection is we want to know what happens to the wrapper. Is the framework smart enough to recognize the fact that the wrapper doesn't do anything? It's just passing the value to the child, and as a result, it can be skipped, right? And it turns out many frameworks are unable to skip that situation. The wrapper will also cause re-rendering. And again, when I say the word re-rendering, I don't mean re-rendering in the sense of the DOM being re-rendering, right? I mean the framework has to do all kinds of checks internally to figure out if anything has changed. And all of these checks basically usually come up as nothing has changed and the framework continues. But it took time and energy to do those checks. And that's why, we would like to avoid it, right? So in Vue, when you do that kind of a situation, what actually happens is that, when the incrementer changes the state, the framework is smart enough to know like, oh, the incrementer branch, I don't need to go there, so I'm not going to enter this component. But because the state is associated with the counter, I am going to re-render the counter, even though the counter doesn't display anything. So it's kind of a wasted operation, right? And then because the counter passes the data to the wrapper, the framework then says, well, I need to now, check to see if the wrapper has changed, only to recognize, of course, it hasn't. And then it sees that the wrapper has passed the data to the display. And then the display gets kind of checked, and then it realizes, oh yeah, the display actually talks to the DOM, and so I'm going to go and update the DOM. And so the point to make over here is that the framework, was smart enough to prune the branch where the incrementer is, but it wasn't smart enough to prune the wrapper and the display branch. Now, people who are experts in Vue, they'll say like, well, that's okay. There is a way to work around this by, doing extra work from the point of view of the developer. And that's true. You can do that. You can kind of help the framework. But I think it's worth having a discussion in the form of like, well, how does it work out of the box? What is the default behavior? Like, yes, I can always optimize the framework, but like, what is the default behavior out of the box? And I think this is worth having because if you like do documentation and reading, etc., they'll tell you to do this thing and this thing will behave this way. And then they'll have a separate documentation that says like, okay, well, if this becomes a problem for you, then go and, do additional optimizations, additional tricks to kind of fix this up. So that's how Vue works. And it turns out Svelte works in very much the same way, except that Svelte is really good at detecting when there are no bindings. So Svelte has a compiler, and the compiler basically looks at how you're passing the data around, and it can short circuit a lot of things. And so from that point of view, I would say Svelte is more reactive than Vue because this compiler can do all of these tricks and it can kind of filter things out. So from a computational standpoint of view, there's less work to be done. But from the logical point of view, the two frameworks actually work the same way. You have these kind of two trees. But what's interesting about Svelte is that Svelte is as a compiler, but the compiler runs only on Svelte files. And so when you want to do reactivity outside of a Svelte file, which is sometimes necessary, you actually are forced to have different components. So outside of Svelte files, they have something called a store. And store, in a way, is something similar to what Vue has. Vue has refs or signals. It's kind of similar, but slightly different. Stores are kind of halfway between signals and like RxJS observables. But I mean, the details are not important. But what I find interesting is that it actually has two different syntheses, right? If you are within a template, within a Svelte file, then everything just happens magically. And, the compiler is really good at kind of figuring things out. And you have one syntax for binding two values. But if you need to have value from outside of the world, from a store, they actually have a different syntax for binding. And this is kind of an interesting trade-off, right? Because Vue basically says, no, there's only one way to do kind of reactivity graph, and they have this thing called refs, right? And these are all runtime things. And because they're runtime things, they're consistent whether or not you're inside of a Vue file or whether you're outside of the Vue file. In Svelte world, they have really two things, right? Inside of the Vue file, the compiler does all this magic and you don't have to think about it. It just does the right thing. But outside of a Svelte file, if you want to have reactivity, then you have these things called stores. And it's actually is kind of interesting to me that as a Svelte developer, you now kind of have to juggle two different mental models. Anyways, when you are inside of a Svelte file, the way reactivity works is the same exact way, where you modify the state in the root component, which in this case would be the counter. And then that, after executing the counter, it has to go and execute the wrapper. And after the wrapper executes, it executes the counter. And then the counter actually causes the UI to change. And Svelte is really good at doing all this stuff really efficiently. But I think the point is that because all of these components have to execute, the code has to be present, right? And because the code has to be present, it can't be lazy loaded. So, Angular, React, Vue, and Svelte, in this sense, have this particular side effect that they require all the code associated with components to be available. Now, because Vue and Svelte do a better job at pruning the things, less code can be required. And when I say less code is available, that means more choices for you to do lazy loading, right? Because the code doesn't have to be present. As part of, if I click on a button, I don't have to have these particular parts. And so if you're just using .svelte files, then the counter has to be present, the wrapper has to be present, and the display has to be present. But if you're using the stores, which is the runtime reactivity, then it turns out you get to skip the counter and the display, the wrapper. You only have to update the display.
But how is it in the case of quick and solid?
So quick and solid are very similar, but there is a difference. And that is, the first thing that I want to point out is like solid makes a point out of this fact that if you have a reactivity graph, you no longer need the components, right? So when things change, the components make no difference as far as solid is concerned. And therefore, solid will never re-execute kind of unnecessary components in our tree, right? So when you click the increment button, the counter or the wrapper doesn't get executed, just the display gets, not even the display, like the Svelte directly knows which DOM element to go to and update. So from that point of view, I think solid is by far the most extreme in terms of like, if you take the idea of reactivity and take it to the absolute extreme, this is where you end up with. Quick is kind of halfway. So if the update that you're doing is just like incrementing a value, so all you're doing is just updating kind of the text of the DOM, then quick acts like solid. But if you are changing the DOM structurally, like if you're adding or removing DOM elements, then quick has to re-execute the component. So it kind of straddles the two sides. But the nice thing that the quick knows how to do is that it knows how to, for the most part, not re-execute the components. And the reason why this is important is because that means those components don't have to be downloaded to the client, right? By having this very clear reactivity graph and knowing where to go update, Quick doesn't have to download the components. And sometimes when Quick has to re-execute a particular component, the thing Quick knows how to do is how to make sure that neither the parent or the child component have to be present, right? So it knows how to just execute the component by itself and don't cause any cascading kind of issues. And if you look at what we talked about before until now, really all the other systems have this cascade behavior, right? That they start at a particular component which contains the state, and then they have to cascade to the child component, etc. Some systems are better than others at pruning the tree, so that's definitely a plus. You have less work, but they are all require the components to be present. Now, the place where it really becomes a huge difference is what happens on hydration. And you see, the thing is, solid is unbelievably fine-grained, right? It never has to re-execute the components, which is great, except for the initial hydration. In order for solid to build up the reactivity graph of everything that's happening, it has to execute all of the components in the tree so that it can learn about the reactivity graph. And once it learns about the reactivity graph, those components never, ever re-execute, right? And so that's amazing, but we already paid the price of downloading and executing them, right? And same thing is true for every other framework, Angular, React, Vue, Svelte, etc., right? They all have this property that in order to figure out what the reactivity graph is, they have to download and execute all the components in a tree, right? Once they understand what the reactivity graph, there is a differences between, whether or not they have to re-execute the components. And again, there's a spectrum, right? One extreme is like React and Angular, which re-executes everything all the time. The other extreme is Solid, which never, ever re-executes anything after the initial render, right? But they all have to download and execute everything at least once, except for Quick, right? Quick is the odd man out over here. So Quick knows how to transfer basically the reactivity graph from the server to the client, right? Because when you were doing server-side pre-rendering, when you're running the application the very, very first time, you really have no choice but to execute everything, right? Like this is how the framework learns about the application, right? The trouble here is that the reactivity system of everybody else is to say like, okay, when you get to the client, you need to learn what the reactivity graph is. And the way these frameworks learn what the reactivity graph is they re-execute the application just like they re-executed it on the server. And this is the differentiation of Quick, where the Quick says like, well, I already executed on the server. I already know what the reactivity graph is. And so I'm going to serialize the reactivity graph somehow into the HTML in such a way that when the framework, wakes up on the client, it doesn't need to re-execute everything, right? It only has the reactivity graph. And sometimes in the future, as you interact with the application, Quick may be forced to download a particular component, but because Quick tries really hard not to cause this, tree-based reactivity where you start with a root component and, re-execute everything from there, as we kind of pointed out with Angular, Vue, and Svelte and React, it has an advantage in the sense that it can lazy load components that are currently in the render tree, but don't have to be re-rendered, right? Whereas all the other frameworks, they want to, in order to kind of learn what the reactivity graph is, in order to do their magic, in order to be efficient at not calling components, they at the very least, at the very beginning, have to execute everything at least once, which is kind of where you kind of lose the benefit of having lazy loading, because if the components have to be downloaded and executed, you don't get the benefit. So Solid is definitely the most fine-grained out of the bunch. And Quick is a close second. Like Quick in many cases behaves just like Solid, but in some cases, Quick behaves more like a super optimized Svelte or a Vue case where it has to rerun the components. But it doesn't have to do the initial learning. That initial learning was transferred from the server to the client, whereas everybody else has to do the initial learning. And as part of the initial learning, they have to download and execute all the code. And this is why hydration is so expensive in all other scenarios.
By the way, not so long ago, I spoke to Antoine, who is, let's call it, positively obsessed with performance.
He's obsessed. Yes. And he's absolutely obsessed. And I think it's a good thing. I think a lot of people give up. Yeah. They know this is good in practice. They know it is the right thing to do. But I think this is a problem of human nature, right? Like who is kind of the source of the problem, so to speak, and who is suffering from this? And the best kind of systems are the ones where the person who is causing the problem and is suffering the problem is the same person, right? Because if it's the same person, the right things just happens out of the box.
Yeah.
If it's not the same person, then you have a broken feedback loop and you don't have feedback. And because you don't have feedback, people just tend not to care. So I find Antoine to be kind of an oddity, right? Because, somehow he understands that there is a loop, right? For him, in order to close the loop, he understands that if the website is slow, then people won't use the product. And if the people won't use the product, the company is not going to be successful. And then, that comes back to him and he's out of the job, right? But it's a much longer circle. And most people kind of don't usually connect all these points that at the end, it actually comes back to me anyways. But the tighter the circle is, the more direct the response and more people care, right? That's why developers really care about developer experience, the DX, because it's a very tight circle. They feel it all the time, and so they want to make their life better. Whereas performance is something that's like really somebody else's problem. And because it's somebody else's problem, it's harder to get people to care. So the trick is, can you deliver a good DX, something that developers enjoy, but at the same time has a good output? And actually, let's go back to reactivity. I think this actually ties very nicely. And that is, we talked about what these frameworks do out of the box in terms of reactivity. And I think there's a point to be made, which is that many frameworks have this developer experience that says like, okay, build your app this way. And then when you have a performance problem, do these additional steps to kind of fix it, right? Whereas I think what you want is you want to make sure that the performance path and the easy path is the same thing. In other words, in many of these frameworks, the performance path, or rather the path of good DX, the thing that makes developers happy, and the performance path are not the same thing. And so it means that you're good at building up complicated application, but then somebody else needs to go back and like fix things in terms of performance. And I think it's actually interesting because I was watching a video of somebody, I don't remember who it was, and they were comparing the DX of React versus the DX of Solid. And I found this interesting because they're, when we talk about it, they're on the opposite extremes of reactivity spectrum. And their point was that in React, the reactivity always kind of works, right? As long, you can change whatever you write your code, and you know that things will always work. True, but you pay for it in form of, over time, your application may get slow, and then you need to come back and optimize things. And when you optimize things, you are actually running the risk that you break reactivity, right? So React out of the box and Angular is the same way, right? Again, those two are really interchangeable in terms of how they work. They have this nice property that reactivity just works all the time, right? Except that you pay it in the form of performance, and then you have to go back and, you have the experts that will tell you how to not run change detection all the time in Angular, and they'll tell you how to prune branches in React and how to use onPush in Angular and so on and so forth, right? It's an optimization step that happens after the fact. And whenever you're doing this optimization step, you're running the risk of breaking the application, okay? If you go on the other extreme, such as a signal system like Solid, there the kind of the mentality is slightly different, which is that you need to follow certain rules in order to stay within signals, right? And as long as you stay within signals, then the system is extremely performant. And it's really the most performant it can theoretically be, given, you have sufficient knowledge of everything. And so Solid really is the extreme example of this particular thing, where they just said, like, let's just take these signals to the actual logical end conclusion, right? And so the problem with all signal-based systems, not just Solid, is that it's possible to fall out, right? It's possible for you as a developer to do things where you accidentally fall out of the signals, and then your application doesn't work. But here's an interesting thing. When you mess up in Solid, or rather in any signal-based system, but let's use Solid as an example because it's the extreme. When you mess up in Solid, the result is your application does not work. It's broken. Whereas if you mess up in the other extreme, like Angular or React, the application is not performant. And I'm going to actually argue that it's better to have a broken application than a non-performant application, because the non-performant application is a death by 1,000 cuts, and there isn't any one clear thing to do to fix the problem. Whereas if you broke your application, you fell out of the signal world, so to speak, inside of a signal-based system, then your app is just broken, and it's very obvious what to do and how to fix it. So I think that many people kind of view signals as like, oh, look, I can't just do anything I want. But I actually think that that's actually a good thing, because when you mess up, the cost you pay is very obvious. Like, the app does not work, and you know how to fix it, and that gets you back on track. Whereas if you mess up in the other extreme, the cost is slow performance for the end user, and that isn't like one mess up, now you're slow. It's like each mess up adds a little more stuff. And then as a result, by the time you realize the application is slow, there isn't one fix you could do to kind of fix the problem, right? It's spread across everything. And so this particular person actually was talking about it as a problem that you can fall out of reactivity in signal-based system. But I actually think of it as a positive thing. It's an early warning system of saying, like, hey, you're doing something that's not following the rules. Don't do that, right? Versus just silently continue working and causing a slow response for the end user.
Miško, I am grateful to you for our next super valuable conversation. Thank you all for tuning into today's episode. If you found our conversation insightful and wish to continue being a part of our journey, please consider subscribing to our podcast. By doing so, You won't miss out on any upcoming episodes, and it helps us continue to bring you meaningful content. Remember, every subscription, like or share truly make a difference. Until next time, stay curious and keep listening.